All right, so this is 2.2 notes. So in 2.1, we learned about graphs of quadratic functions, so that's our x squared graphs. In 2.2, we're graphing polynomial functions, which poly means many, so they're going to have many terms of higher degrees. So we're going to be graphing x cubed, x to the fourth power, x to the fifth power, all that fun stuff. So a polynomial function graph is continuous, meaning that it has no breaks, no holes, no gaps. Like in this picture down here, our graph is continuous, it doesn't stop. Unlike this one where it has a gap here, this would not be continuous, so it's not a polynomial function. So this says that a function is continuous when its graph can be drawn with a pencil without lifting the pencil from the paper. Another feature of our graph of a polynomial function is that it has only smooth, rounded turns. So polynomial functions are always continuous and always smooth. So it won't have any sharp edges. Like it won't go like this. It's going to have a smooth, continuous ride throughout our graph. So again, here it says it cannot have a sharp turn, such as the picture here. Polynomial functions of degree 1 are lines, so that would be our y is equal to mx plus b. Our degree here is 1, so this is a line. Degree 2 would be an x squared graph, which that's a parabola, which is what we did in the last section. Again, here it just says the same thing. All polynomial functions are smooth and continuous. Bless you. A polynomial function of degree n has this form, so it just starts with your highest degree and then goes down until you're constant. So when n is even, this would be for x to the fourth, x to the sixth, any even number exponent that you have. When your exponent's even, the graph is similar to the graph of our f of x is equal to x squared, our parabola, and touches the x-axis at the x-intercept. So our graph is similar to a parabola shape. Thank you. Thank you. When n is odd, so that would be x cubed, x to the fifth, x to the seventh, all those types. Our graph is similar to an x cubed graph, which x cubed graphs look like this. It kind of snakes through our origin there. So that would be our x cubed graph. So going back to example 1, the slide before the last two. Our leading coefficient is positive or negative? It's negative. And is our exponent even or odd? It's odd. So we're going to go in opposite directions. And it's negative, so we're going to be decreasing. So we start going up and end going down. So our negative x cubed graph starts going up and ends going down. And it has that shape of the x cubed graph. For b, our leading coefficient is positive or negative? Positive. And it's again odd, so we go in opposite directions. So we're eventually increasing in our slope. So we start going down and end going up. So our graph would look like this. But what does that plus 1 do to it? It moves it up 1. So we just take our parent function of our x cubed and shift it up 1. Bless you. So this plus 1 moves it up 1. So we just took our parent function, shifted it up. In C, what does this minus 1 on the inside do? Shifts it to the right 1. So we would take our parent function graph. It's positive, and it's x cubed, so that's our parent function, and we just shift it to the right 1. So it would look like that. So to determine what our graph is going to do when we have a polynomial function, there's two things we want to look at. We want to look at the coefficient, the leading coefficient, and we want to look at the degree. So we care if the degree is odd or even. If it's odd, our end behavior of the graph, so those arrows down at the start and at the finish, are going to go in opposite directions. So when it's odd, your arrows are going to go in opposite directions. If your leading coefficient is positive, your graph starts going down and ends going up. So just think about it as your slope is increasing when your leading coefficient is positive. So it starts going down and ends going up. If your leading coefficient is negative, then it does the opposite. It starts going up and ends going down. So just think about it as it's eventually decreasing. So our end behavior of our graph, when our exponent is odd, end behavior goes in opposite directions. When it's even, it kind of looks like a parabola. Our end behavior is going to go in the same direction. So if our leading coefficient is positive, your end behavior is going to go up and up. If your leading coefficient is negative, it's going to go down and down. So when it's even, it goes in the same direction. All right, in example 2, we're just applying the leading coefficient tests. So it says use the leading coefficient test to describe the right and left hand behavior of the graph. So is our leading coefficient positive or negative? Negative. And is it even or odd? It's odd. So is it going to go in the same direction or opposite directions? Opposite directions. So is it going to start going up or start going down? What's our left behavior going to do? Starts going up and then it ends going down because that negative means that it's decreasing. So the way that we would word this is our left arrow is going up, so it rises left. And then our right arrow is going down, so it falls right. It doesn't matter. All we're doing is looking at our highest degree term. So that's the only thing that determines our end behavior.
You always read these from left to right, right?
Mm-hmm.
So if they put like negative x cubed plus 4x equals to f of x, like they just move the f of x to the other side of the equation, you would still read it left to right.
Right. So even if this was f of x here, you still read it left to right.
Okay.
Even if it was 4x minus x cubed, we're still looking at the highest degree term. So just be careful because that's not always going to be written first.
Okay. So
But that's the one that determines the end
leading
behavior.
coefficient isn't the first one of the problem,
Right.
It's just the biggest one.
It's the one with the biggest degree.
Mm-hmm.
Mm-hmm. On the next page, We have to find the zeros of our polynomial to help us find where we cross the x-axis. So we can find the zeros, which is the same thing as saying finding the solution, which is the same thing as factoring, which is the same thing as the x-intercept. So all of these words kind of mean the same thing. Factor is a little bit different because factor is like the step before finding the zeros in the solution and the x-intercept, but they all mean the same. So that's where we cross the x-axis. So our zeros, whenever we solve for x, are going to be those points where we cross the x-axis, our x-intercepts. So for example 4, we have to find all the real zeros of x cubed minus x squared minus 2x. So that means we have to factor. What do I need to do to factor this?
Take out an x.
Take out an x, so then I'm left with x squared minus x minus 2. What should I do next?
Combine x squared and 2x.
Do I have two factors of negative 2 that add to negative 1? Negative 2 and positive 1. So that would give me x times x minus 2 times x plus 1. I'm finding the zeros, so I just set this equal to 0. And I need to set each piece equal to 0. So x is equal to 0, x minus 2 is equal to 0, x plus 1 is equal to 0. So x is equal to 0 is already one answer. Don't need to do anything there. Second one, I can add 2 to both sides. So x is equal to 2. And then the third one, I just subtract 1. So x is equal to negative 1. So those are my zeros. I think there's only one example in these notes where we actually have to graph it. So I'm going to graph this one with you guys just so we can get an idea of what it's going to do and what we need to do. So first thing I want to do is plot all my zeros on the x-axis. So I'm going to cross the x-axis at 0, at 2, and at negative 1. Next thing I want to do is look at my leading coefficient and determine my end behavior. So is it positive or negative? Positive, which means that it's going to be increasing in the slope. And then is it even or odd? Odd, so that goes in opposite direction. So it starts going down and ends going up. So whatever arrows you found here starts going down, you just put them on the farthest point to the left of your graph and the farthest point to the right. So it ends going up. In between, we're only going to cross at these purple points. So we just cross the x-axis at those points and just connect the dots. And that's our graph. All right, so next we talk about multiplicity. So whenever you have a repeated 0, that gives us multiplicity. If our multiplicity is odd, then the graph crosses the x-axis at that point. If our multiplicity is even, then our graph just touches at that point. So let's say I had, when I found my zeros, x is equal to 2 and x is equal to 2. Because that 2 repeats, this gives me multiplicity. I should have not used 2. Let's say x is equal to 3 and x is equal to 3. It gives me multiplicity of 2 because I have 2 3's at 3. So if I were to graph this when x is equal to 3, 1, 2, 3, at this point, I don't go through, I just touch it and turn. So this is when your multiplicity is even, if it repeats just twice.
But how would that happen if it touches 2 different areas?
It touches just at one point here. So it touches at 3 because it's the same number. So it touches and turns.
Okay, but if it's 2 different numbers?
If it's 2 different numbers, so let's say, like in the last one, They were all different numbers. We didn't have any multiplicity in the last one. So all of those points just go through. So if I had x is equal to 0, x is equal to 2. On my graph, here I don't have any multiplicity because all of them are just ones. So at 0 and at 2, I would go through and go through. Yes?
So if it was like x equal to 2, x equal to 2, and x equals -1, how do you graph that? Like there's another x value.
So if there were another x value at -1 here, it would go like back up through.
So the x equals 0 and x equals 2 is when it's odd.
Yeah, when it's odd, because there's only one of them for each. So it's odd, so it goes through.
So you would say, like for 1, the multiplicity of 0, or they have a multiplicity of 1 at 0 and 1 at 2.
When it doesn't repeat, so if it were like a multiplicity of 1, it doesn't have multiplicity, so you don't have to state it. So there would be no multiplicity for this one because it doesn't repeat.
So basically odd is
Odd is what?
multiplicity.
Unless it had multiplicity of 3. That would be odd, and it has multiplicity. So like if I had x equal to 1, x equal to 1, x equal to 1. Yes.
So when it has all multiplicity, it goes through it, like normal?
When it has odd multiplicity, it goes through the point.
Alright.
Or if it was just odd, like for the previous example. First thing I want to do is find my zeros. So what should I do to find the zeros? Factor. How can I factor this? Awesome. Always want to take out your greatest common factor. That would be x to the third here. So x to the third, we're left with 3x minus 4. What should I do next? X to the third is equal to 0. 3x minus 4 is equal to 0. So this x to the third is equal to 0 is like saying x is equal to 0, x is equal to 0, x is equal to 0. Because we have 3 x's that are just 0.
So if it was x squared, it would be x equals 0, x equals 0.
So do I have multiplicity at 0?
Yes.
Multiplicity of what? Odd multiplicity. So multiplicity of 3 at 0. At 0. And it is odd. So odd multiplicity. Odd multiplicity, do I touch and turn or go through that point? Odd multiplicity. I go through. Through.
So if it's all the same solution, wouldn't that just go in the same line? Like if it all touches the x-axis at 0, like all 3 solutions, what would that graph?
It's the same line. But if it were x squared is equal to 0, at 0 we would touch and turn. So it just depends on what the multiplicity is. So here our multiplicity is 3, it's odd, so we're going to go through 0. So that's just telling us the shape of it. It's just one line, but it's telling us the shape. For the next one, we still have to solve. So x is equal to, 3x is equal to 4, divide by 3. X is equal to 4/3. At 4/3, am I going to touch and turn or go through? I'm going to go through because there's only one 4/3. So let's graph. I'm going to cross the x-axis at 0 and at 4/3, which is like 1 1/3. So like there. We need to know what the end behavior of our graph is. So looking at this, is it positive or negative? Positive. And is it even or odd? My degree. It's even. So am I going to go in the same direction or opposite directions? Same direction. Up and up or down and down? Up and up. So I'm going to go up and up. So at your point farthest to the left, you go up. At your point farthest to the right, you go up. And then at both of these points, I said I go through. So I'm going to go through the point and through the point. Bless you. So this is like our rough estimate of the graph. Yes. So the end behavior would just be the end arrows. All right, so we're going to do the first one here. It's a good one to do together since it doesn't factor. But looking at our leading coefficient, what's our end behavior going to be? Up and up. So we would say rises left and right. Next, we want to find the roots. So we have to factor. We can take out a 5 because that's our greatest common factor. We're left with x squared minus 2x minus 1. Do we have any factors of -1 that add to -2?
-1 and -1.
-1 times -1 is what? +1. So we don't. So when you don't have factors, you have to do the quadratic formula. Again, on the quiz, they'll all factor. But this will be good practice. So as a little reminder for us, our quadratic formula is -b plus or minus the square root of b squared minus 4ac over 2a. So our a would be 1, our b is -2, and our c is -1. Then we just plug it into our formula. So we have -2, which would become +2, plus or minus the square root of -2 squared, which is 4, minus 4 times 1 times -1 over 2 times 1. So this would be 2 plus or minus the square root of 4. This would be 4 plus 4, so 8 over 2. Can we simplify the square root of 8?
Yeah.
So it breaks down into 2 times 2 times 2. We have a group of 2's that I could take out, so this would be 2 square root 2. So I have 2 plus or minus 2 square root 2 over 2. Can I simplify this? What does it simplify to? Awesome. 1 plus or minus square root 2. So my roots would be, yeah, I'll go back. 1 plus or minus square root 2. There. So if my zeros, because technically this is 2 here, right? I have 1 plus square root 2, 1 minus square root 2. Are these the same thing? No. So just because it's plus and minus doesn't mean it's the same thing. That's 2 different numbers. So this would be odd multiplicity because it's only 1 time for each. So
Wait, this is gonna sound like a dumb question.
there's never dumb questions.
Where did you get, like, I don't know why I'm not getting this, the square root of 8, because it's 4 times -1. Maybe I'm just not seeing it right.
This would be 4 minus 4 times -1 would be +4, so it becomes a +4.
Oh, okay.
Yeah. Sometimes I make silly mistakes, so I'm glad that you're questioning me.
Are we just gonna forget about the 5 in front of the factoring, like, because it's just 5 equals 0?
Right, so this is equal to 0, so I divided all of this by 5 and this by 5. So then I would just factoring the x squared minus 2x minus 1. If you didn't do that and you factored right from the start, or you plugged it into the quadratic right from the start, so you used a is equal to 5, b is equal to -10, and c is equal to -5. I think I did this in the answer key where I plugged in these numbers. It simplifies to this.
Okay.
What do we put for the disintermediate x across? We just put like no.
So 1 plus square root 2 and 1 minus square root 2. Do I touch and turn or cross through? I go through. And I go through. Because at both of these points, there's no even multiplicity. It only happens once.
I just want to know what there, because that's kind of like a.
So since it's odd, it crosses through.
Yep. So since it's odd, it goes through. And then we could graph this. Thank you. So we cross the x-intercepts at 1 plus square root 2, which would kind of be like 2-ish. A little bit more than 2. So like here, I could say. And then 1 minus square root 2, which would be a little bit in the negatives over here. And at both of these points, I go through. And my end behavior I said was up and up. So I'm going to go up, and at the points I just go through. So my graph kind of looks like this. The way I think about it when I think of like what number this is that the square root 2 is kind of like 1-ish, because it's in between, like the square root of 1 would be 1, the square root of 4 is 2. So it's like somewhere in the middle, so that's why I think of it as like 1 plus 1-ish, so like 2 point something. So it's just an estimation. Same thing with this. If it's 1 minus 1 point something, it would be like kind of negative point something-ish. So you're going to factor on the quiz. You won't have square roots where you have to plot the square roots. So first thing we could do is find the y-intercepts. Also, we have to find the end behavior, but that's going to help us with the graph. So that kind of goes with that. End behavior. Oh, it does say end behavior here. So, what should I do first?
Find the zeros.
I can look at the coefficient and determine the end behavior. So is it positive or negative?
Positive.
Positive. So it's going to be increasing. And is it even or odd? Odd. So they go in opposite directions. So it starts going down and ends going up. So I would say for my end behavior, this falls left because it's going down for the left arrow, and then rises right. I also want to find my zeros, so I'm going to set this equal to 0. What should I do next?
Take out next.
Take out an x. I have a greatest common factor of x. So I'm left with x squared minus 3x plus 2. What can I do next?
X, or you can divide out x. I would divide out x because it just like helps visualize it better. But what you could do after that is you could you could factor x squared minus 3x.
So I want to factor. Do I have two factors of 2? That adds negative 3.
Negative 2,
Negative 2, negative 1. So this would break down into x times x minus 2 times x minus 1. What should I do next?
Find zeros.
Find the zeros. So I break up each piece and set it equal to 0. X is equal to 0. X minus 2 is equal to 0. X minus 1 is equal to 0. So x is equal to 0 is done. The next one, I add 2 to both sides. X is equal to 2. And then the third one, add 1 to both sides. So x is equal to 1. At each of these points, do I have any multiplicity?
No.
No. So is it going to go through or touch and turn? Go through, and go through. So I can put it on my graph. I'm going to put all 3 of these points. So I have 0, 1, and 2. So there's my x-intercepts. What should I do next? The end behavior. So I said it's going to start going down. So at my point farthest to the left, so I'm going to put a down arrow. It ends going up, so my point farthest to the right, I put an up arrow. And at each one of these points, I go through. So I go through the point, through the point, through the point. Should not have a sharp edge there. It needs to be smooth like this. So that's my graph.
Ms. Carter?
Yes.
For the multiplicity, will we just write like odd?
You can write it's odd, or if it has like one of each, you can say no multiplicity because it doesn't repeat.
So it's okay if we put.
It's okay if you put none. It's okay if you put odd. Bless you.
Can you do B?
Odd, it always falls to the left and rises to the right, right?
If the degree is odd, it's going to fall to the left and rise to the right if it's positive. So odd just means it goes in opposite directions. Yes. Let's see. Did we answer everything here?
Do we ever write down the y-intercept?
What's our y-intercept
0.
as a point?
0, comma 0.
0, comma 0. So we cross the y-axis at this point, 0, 0. How can we find the y-intercept algebraically?
Make y equals 0 and
So for the y-intercept,
no, you make the x 0.
you make x 0. So you plug in 0 for your x's. So this would be 0 cubed minus 3 times 0 squared plus 2 times 0, which is just 0.